Hi, today's activity we are going to be calculating the intensity and magnitude of stars and comparing these two different ways to describe a star's brightness. Um, First off, make sure that you have this worksheet before you get started. If you don't have it, please pause your video now. I'm going to go over both the formulas. There is one formula on the front that looks like this, and I'm also going to go over one practice problem for each one. Before I get started, I'd like to just describe the formula. It looks very ominous. It looks very hard to describe. As you can see here, we have this IA over IB. These are the intensities of two different stars, and that will be equal to this number, 2.512, to the power of the magnitude difference between these same two stars. Now, for these problems, we don't need to really worry about this side of the equation. This is what we're solving for. All we need to worry about is what's on the right-hand side of the equation, and we need to determine which of these two of these magnitudes is the bigger of the two. Now, in order to understand magnitude scales, I want to talk a little bit about logarithms. So, when looking at the magnitude difference of a star, this is simply telling us how bright one star is compared to another. And the intensity ratio is how much brighter it will actually be. So the magnitude difference is kind of like this scale, like, let's say, degrees Celsius or degrees Fahrenheit, where we're giving a value to an actual real thing. The temperature that you would feel something be is kind of like the intensity ratio. How would it feel to your skin to be in a room that's 70 degrees versus outside at 100 degrees? So our intensity ratio is how it looks like to our eyes, and the magnitude difference is a value in mathematics that we've used to apply to understand those values. A similar way of looking at this would be also the pH scale in chemistry, if you're familiar with that. So for a magnitude difference of 1, you'll notice that the intensity ratio actually jumps by 2.5. So we go from 1 to 2.5. If we have a magnitude difference of 2, however, from 0 to 2, that actually is a difference of 6.3 times brighter. So the difference in magnitude is not a linear scale. Now, if we were to expand upon this and we were to look at each of these values, if we were to look at the first 5 values on this number sequence in a chart form, it would look something like this. So you'll notice that a difference of 1 is not very big, but a 2 makes a big jump, a 3 makes an even bigger jump, and 4 and then 5, you can see that this pattern is non-linear. In fact, if we go from 0 to 10, it's even more dramatic. A magnitude difference of 0 to 15 looks even more dramatic. 0 to 20, even more dramatic. And 0 to 25 magnitudes difference is even more dramatic. In other words, if you were outside, you actually, with your human eyes, can't see much past a 6th magnitude star. The one thing I've been not saying so far is that the higher the magnitude of a star, the bigger the number, the dimmer it is. It's kind of opposite of what you would normally think of, unless you're talking about ranking. So, for example, you'd want to be the number 1 team, and you're going to be going to the playoffs. Or in golf, you want the lowest number. That's always best. So the lower the numbers on this chart, the magnitude chart, the brighter the star is. The bigger the numbers on these charts, the dimmer the star is. So if you have a magnitude difference of 6, then a magnitude 0 star is 251 times brighter to your eye than a magnitude 6 star is. that would be a good thing to kind of write down if you need to rewind this. That's the nice thing about these videos, is you can rewind and re-listen to them. Now to go back to our equation, we'll see that we have the magnitude difference given to us right here. So we have 2.512, the difference of one magnitude, and then it's to the power of the difference between the two magnitudes. So for example number 1, we have a star called Sirius. Sirius is a very bright star at a negative 1.47 magnitude. And another very bright star, Deneb, is slightly less bright at a 1.26 magnitude difference. Now, I'm going to show you the answer for this one. This is how you'd go about calculating it. First, you have to write things down in the equation. So you're taking this equation here, we're plugging only into this side. This remains the same. As you can see, we've got the intensity of Sirius over the intensity of Deneb is equal to 2.512 to the power of the difference between these two magnitudes. So you've got a magnitude difference of 2.73. Now, we get an answer then. If we take this, we take 2.512, we use the exponent on your calculator, and we take this to the power of 2.73, you should get the answer of 12.361. So what I want you to do then, though, is to actually explain this in words. So you can see here that it says Sirius is 12.4 times as bright as Deneb. So that's the first equation. We're going from a magnitude difference to determine what the intensity ratio is. And that's what this number is. This 12.4 is this ratio of IA over IB. The second type of equation is on the back side of your page. And with this one, we have the same formula, but we've flipped it on its head. I'm going to give you the intensity ratio between two stars, and you need to figure out what the magnitude difference between those two stars is. So with this one, you need to use, once again, the right-hand side of the equation right here. This is what I'm going to be asking you to solve for, is the magnitude difference. So here in question number 6, it says star A and B have an intensity ratio of 30. So the intensity ratio is equal to this whole thing. So you would just plug in here 2.512 log 30 from here. And then it says, what is their difference in magnitude? Once again, this can just be plugged into your calculator. This is a log, in this case, is the opposite of that exponential relationship. And so when we plug this 30 in here and do this calculation, we will solve for what the magnitude difference will be. Let me go to your answer page. And when we do this, 2.512 log 30, we'll end up with an answer of 3.71, which tells us that the magnitude difference between these two stars is that there is a 3.71 difference in that magnitude scale, on the scale on the left here. So hopefully this has helped, and hopefully you are good to go. If you have questions, please know that you can always come and ask me. I am more than happy to help walk you through this in person. Thanks a lot.